Hey there, YouTubers! Hi there, Dr. Sheep here. Welcome back to another energy video. Today's part, I don't know, of my multi-part series, The Energy. Today, we're going to the depths of the universe to explore dark matter and dark energy. What is dark matter? That's a good question that we don't yet 100% know the answer to. How do we know it exists? That's an even better question. To answer it, we need to put on our tripping music, close our eyes, and surrender ourselves to the void of space. Keep your eyes closed. You're floating in an incomprehensibly vast void. It's cold, dark, and lonely. The only matter around you are stray protons and helium atoms. You open your eyes to see that you're in an intergalactic space. You look into the distance to see the faint glow of galaxies. Looking at these galaxies, you know how fast they could spin according to Newton's gravitational equations. As you look at them, you realize they're spinning too fast. This would indicate that the galaxies have more mass than you originally estimated. However, the more you look at them, you see that they can't have more matter unless it's invisible. This is the origin of dark matter. So how do we know galaxies are spinning too fast? The answer comes down to F equals ma and Newton's gravitational force equation. Newton's gravitational force equation is F, or the force of gravity, equal to the mass of one object times the mass of a second object divided by the distance between them squared times big G, or the gravitational constant, which is 6.67 times 10 to the negative 11th. Set that equal to ma, cancel out one of the m's from each side. If we do this, we find the minimum mass a galaxy needs at a given rotational velocity to remain cohesive. This shows us that we're missing a large amount of stuff when we find the mass of galaxies. This leads us to ponder what the missing stuff is, and many believe is something called dark matter. If dark matter exists, it seems to only interact with matter gravitationally. However, matter can interact with itself in many ways, electromagnetically, and the strong and weak nuclear forces. Dark matter also doesn't seem to interact with itself. However, how does it interact gravitationally but doesn't attract itself? That last question leads us to two theories. If we continue down the particle path, it suggests that dark matter interacts with matter using a fifth unknown force. This unknown force, like the other four fundamental forces, would have a carrier particle. We call these theoretical particles WIMPs. WIMP stands for weakly interacting particles. Because if they are real, they are very difficult to detect. Another theory as to what dark matter could be is that it is simply large blobs of normal matter about the same size of Jupiter wandering galaxies. These objects are called MACHOs, or massive astronomical compact halo objects. Why, hello there. I have my fun fact book. I'm in my fun fact chair. That means it's time for a fun fact. Today's fun fact has to come back from a comment I made earlier in this video, or I will make later in this video. I mentioned that galaxies are accelerating, and the rate at which they're accelerating is also accelerating. And they've been doing this since basically the beginning of time. Well, if that's true, and they're going to continue to keep accelerating, and that rate's going to continue to keep accelerating, doesn't that mean they could be traveling faster than the speed of light? The answer is yes. And I've mentioned it many times before. Once in my day on relativity in a 200 mile per hour fastball, that matter can't go faster than the speed of light. But the space between the matter doesn't give a crap. It will stretch and bend at whatever rate it wants. So the galaxies, relative to themselves, are traveling at whatever speed. But the space is between them is growing, even though the galaxy isn't moving on that plane of space, if that makes sense. The space is moving. This is the same kind of concept for a warp drive, if you've seen that kind of stuff. So that means that these galaxies are traveling faster than the speed of light. And that means that every day there are galaxies disappearing from our line of sight. Meaning that we will never see them. Ever. Unless, well, we invent a warp drive. Isn't that just fascinating? If we close our eyes and float the void, we ponder our existence in this vast universe. You open your eyes to see galaxies and their motion relative to you. You notice that they are accelerating away from you, and the rate at which they are accelerating is also accelerating. How can this be, you wonder? Scientists have a theory about this. It involves dark energy. One interesting thing about dark energy is that we know how much there is in the universe. Using massive telescopes, we found some of the first photons to ever be created. We gathered it into a picture of the universe about 300 million years old. Using this data, we have found that 68% of the universe is dark energy, 27% of the universe is dark matter, and the last 5% is normal matter and energy. That's right, everything we know and can see makes up 5% of the universe. So, in conclusion, dark matter is attractive, dark energy is repulsive. We don't know how or if they're related. However, we do know how matter and energy are related, thanks to Einstein's equation E equals mc squared. That's it. Phil should never write a script again. But in the meantime, I'd like to thank you all for watching. Please like, comment, share, and subscribe. New videos every other Friday, 2 p.m. Central Time, and good night. Subs for trees, subs for trees, subs for trees, subs for trees. Oh, you're still here? I thought I told you to go home. Oh, you want more? I'm flattered. Check out the playlist. If you want exclusive content, check out my Instagram, Dr_Sheep_YouTube. That's all lowercase. If you want to help the earth, subscribe. When I reach 100 subscribers, I'm going to plant 10 trees. If you feel that's too small, then check out my channel chart where I lay out even bigger goals. Finally, stick around for the next 20 seconds to give me that sweet watch time. Bye.